All right, so today we are going to talk about Ggplot and the grammar of graphics. Yes, question? Let me say a little bit about the midterm, okay? Yeah, so today we'll cover Ggplot and the grammar of graphics. On Friday, we have our midterm exam. I've seen a lot of people posting questions on Piazza and whatnot, and I think there's a lot of good discussion. If you haven't checked out the Piazza, I highly encourage you to at least view and read through some of the questions and responses. I've tried to endorse answers that I thought were good and things like that. Regarding, there's this instruction that says, if bracket 1 bracket is part of the output, you need to include it. And that is absolutely true because it seems like almost every answer will have this bracket 1 bracket as part of the answer, but that is actually not the case, okay? A lot of functions do not return bracket, such as cat does not return bracket. If you print a matrix, it does not return a bracket 1, it returns a bracket 1 comma bracket, okay? And when you print a list, it prints out a double bracket, okay? And it's important that we understand the difference in the output, because sometimes when you're trying to diagnose a problem in your code or whatever, the only clue that you have that something is wrong is that the output isn't being formatted the way you want it to be formatted, okay? There's a question about errors and messages and warnings, okay? You do not need to memorize the exact wording of the error, okay? So if it says like error, missing value needed, missing value or true false needed or something like that, you don't have to tell me the exact message of the error. But you do need to say this will result in an error. You do need to say that there is an error, or you do need to tell me that there is a warning, okay? You don't have to memorize the exact wording of the warning or error, but you do need to know what operations result in warnings, what operations result in errors, because warnings allow your code to continue to run. Errors will stop your code, and it's important to know the difference between those things, okay? Messages you do not have to worry about, okay? A message is just something that pops up that is neither a warning nor an error. It's just something that pops up. These are things like when you load a library and it says stuff like I don't know, filter has been masked from package base or something like that when you do library deploy, or library, something else will also say like loaded package XML or something like that. Those are just messages. They are not warnings, okay? Because warnings appear with special flags, okay? Errors appear with will stop your code. You don't have to memorize the exact words of these things. You don't have to worry about messages. Just you need to know if there's a warning or if there's an error. Okay, is that okay? And the outputs. All right. Any other questions? Okay. I do think the midterm, the old midterm that I've used is a good steady guide. But of course, the actual midterm will have different questions and stuff. Please don't complain to me that the questions are different this time or something. Of course they're going to be different. Okay, so let's talk Ggplot. Okay, the GG in Ggplot 2 stands for Grammar of Graphics. Grammar of Graphics is kind of a system that Leland Wilkinson created that provides a formal and structured perspective on how we understand basic data visualization. Okay, so there's this big thing of that people want to be able to visualize our data, and to us that means like making graphs and stuff that look fancy and pretty, and that's part of it. But really, what we are trying to do is we are trying to convey information in our data table. Okay, we've got a table of data, and we're trying to convey that information graphically, okay? And there's some thought and process that goes into it. And Ggplot is a package that Hadley Wickham wrote up to implement this grammar of graphics system created by Leland Wilkinson, okay? It's not meant to be the only way to do graphs, okay? You should have learned base R graphics in Stats 20, and I use base graphics, Stats 20 base graphics, or regular base R all the time, okay? So base R graphics is something I still use all the time, but I think it's useful to learn Ggplot because Ggplot does implement this grammar of graphics, which for more complicated graphics can be very very useful. Okay, and so the idea behind the grammar of graphics is that there is a mapping from properties of the data to visual properties in the graphic. Okay, and so we might have a data where one column is where you have two numeric columns. You've got a column for weight and a column for height. And if you have a data frame where one column is weight and one column is height, and you say, well, let's make a graph, probably naturally you'd say, well, let's make a scatter plot. Okay, and what we're going to do is we're going to graph points, and we're going to put the weight on the x-axis and height on the y-axis. Okay, and that's fine. If we think about that at a slightly abstract level, what we are doing is we are graphing a point, and a point, or this dot, has aesthetic attributes. It's got an x location and a y location. And what we have done is we have mapped the x location of the dot to the column, what did I say, weight, okay? And we've mapped the y location of the dot to the column height. So we have mapped an attribute of our data, one of the columns in our data, to an aesthetic attribute, okay, or a visual visual property of this dot, okay. In a different graph, we might make a bar chart, and we might say, you might have a bar chart for people in North Campus majors versus South Campus majors, and I don't know. And you might have a count of this, okay? And you might decide to change the color of the bar based on some other attribute, like the gender of the person, okay? And you might say we're going to graph, females or people who identify female as, red, and males as green or whatever, okay? And that might feel completely different from drawing points to say, points represent weight and height, but the idea of an visual attribute, okay, the color of a bar being mapped to the variable in our data at an abstract level is the same. We are taking a column of our data and turning it into a visual attribute, okay, whether that be the position, horizontal or vertical position, or the color of the point, or the color of the bar, things like that. And that's what the grammar of graphics makes explicit, okay? In base graphics, there's kind of this implied relationship whenever we do these charts, but the grammar of graphics makes that mapping of one variable to an aesthetic attribute very explicit, okay? So here we're gonna just kind of start with a contrast and just say in base graphics, this is how things might be drawn. Okay, so I start off with a matrix, okay? This is a 2x3 matrix. The column names are A1, A2, and A3, and the row names are B1 and B2, okay? And we've got 6 values here, all right? And so we might say, well, let's graph this, okay, with a bar chart. Okay, and if we graph this with a bar chart, we can say bar plot take our matrix simple data and plot it like this, okay? And so we can see, you know, this column which had 10 and 9 appear here. This is 10 and this one's 9. And over here we have 7 and 11, and we have you know, black for 7 and light gray for 11, and the height of this bar right here for A2, and A3, you know, has 12 and 6, and so we have a bar for 12 and a bar with a height of 6, okay? We probably need to include a legend that says black is B1 and light gray is B2. That's not included, but we'd probably want to create something like that as well. Okay. When we created our plot, it groups A1, A2, and by the A variable, A1, A2, and A3. If we want to group by the B variable, we can do that. And in base graphics, this would require us to transform our data and by transposing it, okay? So we transpose this, and we get the column B1 here and the column B2, okay? And we can say, make a bar plot of the transposed data, and we have B1 here, and we can see the column B1 has 10, 7, and 12, and indeed we have a bar at 10, 7, and 12. And likewise, we have one for what, 9, 12, and 6, or 9, 11, and 6 for B2. And again, we would probably need to create a legend that says black is A1, gray is A2, and light gray is A3, okay? And I don't know if you've ever tried to make a legend in base R graphics. I don't know if you've ever tried to do that, but it's often not a fun experience. It's often tedious and frustrating because there's all these things you need to specify. You need to specify the list of labels. You need to specify the kind of the vector of attributes and the position of where this legend is going to go. These are just things that you've got to worry about. Okay, so so that's what happens. If we wanted, instead of bars, to make a line graph, then we wouldn't call bar plot. We would call plot. Okay, we would call plot, which would draw a new graph, and we would say type equals L for lines. And then if we and that would do one row of lines, okay, or one row of values. And then for the other row, we would add the command lines, okay. And so so this is what we might do. We might say plot simple data row 1, okay, type equals L, and that produces this line 10, 7, 12. And then we would say add a line using the command lines simple data row 2, type equals L, color equals blue, and that goes 9, 11, and 6, okay? There's a few things weird things that happen, okay? Notice along the x-axis, we end up plotting, it says index, okay? It should say A1, A2, and A3. Those are the category labels that we've got in our data, A1, A2, and A3. But it says 1, 2, and 3, and it treats it as if it's a continuous variable, giving us 1, 1.5, 2, 2.5, and 3, okay? The other issue that we run into is that our vertical axis goes from 7 to 12, because when we called plot on the first row of data, it says, oh, the smallest value you have is 7, the biggest value you have is 12. I'm going to fit my vertical axis to go from 7 to 12. And when I added the second line of data, which went 9, 11, 6, because we're adding it to the plot, that number 6 doesn't appear on our graph. It goes down, and it implies that it ends in 6 here, but it's not seen in our graphic because the axes of this thing was specified when we first called plot. Okay, and so it's not a big deal to change it. You would just have to go back, rerun the command, and add something like y limits is equal to 6 to 12 and stuff like that. And then again, you would need to add a legend to say the black line is B1 and the blue line is B2. Not a big deal, but it's just stuff we have to think about and concern ourselves with. And it is important to note that we had to significantly change our command in order to do this. Okay. Ggplot is one reason why it's so useful is that it implements this grammar graphic system that says, okay, first of all, your data has to be tidy, and then we can just map columns of our data to aesthetic attributes, okay? And so it changes the way we kind of produce the graphs, okay? One hurdle for using Ggplot, though, is its requirement for the data to be tidy, okay? Ggplot was written by Hadley Wickham, and he has this, very strong opinion about how data needs to be formatted, and that's why he created the tidyverse, right? So we've had a lot of focus on what it means to have tidy data, and so in order to use Ggplot, you have to convert your data to tidy form. And this can be a hurdle for a lot of people because you might have data that's not tidy and you just want to start working with it right away, and maybe some of the base graphic functions work well in that way. But for us, we've got to take our data, okay, so if you recall our data, it looks originally like this matrix, and we need to make it tidy. So what I'm going to do is I transpose the data, so I have this, and then this is actually row names. It's not a variable. So what I'm going to do is I take the transposed data, I make a data frame out of it. I take the row names and I create a column called a value, okay? And then I use the gather to, because right now the data is spread across two columns and I want to gather them into a single column. So I use the function gather, and now our data is in tidy form, okay? But this is something that you need to do if you want to use Ggplot. You've got to make your data tidy, otherwise Ggplot is not going to work, okay? And so this can be a hurdle or a barrier to entry for the usage of Ggplot. And so a lot of times, if it's just a quick graphic that I'm trying to make, I'll just use base graphics and just do something there, okay? But if I want to do something a little bit more intricate, it's often worth the time to make the data tidy, and then graphing the plots are a little bit easier for me, okay? All right, so anyway, we have our data now in tidy form, and we've got the a variable, a value, A12, A1, A2, A3, and the b values B1 and B2 put in our columns, and our value in the value column. Okay, so we're going to make our first group bar graph, okay? So we're going to try to replicate this thing using Ggplot, okay? And in the beginning, it's a little bit of a hard sell for Ggplot because to make this with bar plot, it's very easy, right? You just say bar plot on the matrix and it does it. And in order to use Ggplot, we had to convert our data into tidy form, and now we're going to do this. But I just want to show you some of the nice things about this. So first, what we want to do is we want to map the a variable, the a value column, to the x position. So on the horizontal axis, we're going to have one spot designated for A1, a spot designated on the horizontal axis for A2, and a spot designated for A3, okay? A lot of times we think these x-axis or y-axis is reserved for numeric variables, but it works just fine for categorical variables. Every time you make a bar chart, you're mapping the variable to a location on the x-axis. It's just, you might have said, red cars go on this position of the graph, gray cars go on this position of the graph, white cars go on this position of the graph, or something like that, okay? You're just mapping the categorical variable to a position on the x-axis, okay? What we're going to do now is we're going to say the fill color, the color of the bar, the fill color of the bar is going to be determined by the b value, okay? So B1 will be one color, B2 will be another color. And then the height of the bar will be equal to the value, okay? And then we tell it to draw it with geom bar, okay? So here we go, we call Ggplot2. We say our data is from the simple tidy data, okay? A values get mapped to the x-axis, and we can see A1 is on this position, A2 is here, and A3 is here. And then the B value gets mapped to the fill, okay? So B1 becomes red and B2 becomes blue. It automatically creates a legend for us, okay? And then we have a couple options in geom, okay? So the height of the bar is determined by the value, and we use stat equals identity, okay? Stat equals identity is because the default value or default version of this geom bar is to use a count, okay? And so what it would do is it would treat the this value column as if it were categorical, and we would count how many times did I get, I don't know, the number 5 or something like that, okay? But we want to say, no, don't try to count how many times you got 5. Give me the height of 5 or 6 or whatever it is, okay? That's what I want to graph. Okay, and position dodge says instead of stacking them on top of each other, have them go side by side, okay? Okay, what if I wanted to switch it the other way so that I have B1 over here and three colors for A1, A2, A3 grouped together B1, and then another group of 3 bars for B2. What would I do for the command there? Yeah, I would say not X and Y. I would say X is going to get mapped to B value, okay? B value, we want B1 on this position of the X-axis and B2 on this position of the X-axis. And then we're going to map the fill color to the A value, okay? The A variable value gets mapped to the fill color, okay? And so that's what we would do. So to switch things so that B goes on the X-axis and A's determine the grouping, we would say X is equal to the B value and fill is equal to the A value, okay? We don't have to change the data. The data is already in tidy form, so there's no modifications there. We don't transpose the data or anything like that, okay? And then here I talked about stat identity and things like that. And so here we say B value gets mapped to X, A value gets mapped to fill, and indeed this creates the plot that we have, okay? And again, it creates our legend for us automatically, okay? Or we might call this a guide that, A1 gets mapped to red, A2 is mapped to green, and A3 is mapped to blue, and so on and so forth, okay? So, so this allows you, Ggplot, once your data is in tidy form, it's just a matter of reassigning which variable, which column gets mapped to an aesthetic attribute. Here, we might want to do a line graph, okay? And so for the line graph, we call Ggplot, and this time we said the A values get mapped to the X-axis, and then the color of the line is determined by the B value, okay? And we say group B value just to kind of to separate the lines so that they're not all connected as one thing, okay? And this is what happens here, okay? So we have a line here. We notice, okay, that that the data fits entirely in the plot, okay? The Ggplot fits it, so changes the scales of the vertical axis to fit the entire data set, not just the first line we create. And then it keeps the x-axis as categorical, okay? It says this is A1, this is A2, and this is A3, okay? It doesn't try to make it like a numeric variable. Okay, and this says exactly what I just said, okay? And it also automatically generated those legends for us, which is quite nice, right? This making a legend in base graphics is one of the most frustrating aspects, and the fact that Ggplot does this for us automatically is quite nice. Okay, we have some terminology to go through, okay? And these are things that we should think about. Okay, so first, the data is basically our data. It's what we want to visualize, and again, it's very key that our data is in tidy form, meaning that each variable is in one column, okay? Each column is a variable, and each variable has its own column. If it's not in tidy form, Ggplot doesn't know what to do, okay? Because basically, the way you tell Ggplot to make graphs is you say, this column gets mapped to an aesthetic attribute, and if that column isn't a variable, it's going to get confused. Geoms are geometric objects, okay? Things like bars, lines, points. There's a lot more geometries, geometric objects that you can plot and make graphics with, but these are probably the most common things that we use, okay? Geom bar geom line, geom point, bars, lines, and points. These are the ones that we'll cover in our class, and we'll get through a little bit today, and then we'll have to carry on Monday, okay? Because you have your midterm on Friday. So we'll get through some stuff today. I'll talk a little bit more about it on Monday. And we're talking, bars, lines, and points. These are going to be the basics, and you can always look up the other stuff in the thing, okay? Each of these geometric objects have aesthetic attributes, okay? So a point has aesthetic attributes such as its position in the x direction and its position in the y direction. A point has other attributes like the size of the point. It can be big, it can be small, and you might have a plot where the size of the point represents the population of the country, and so a big circle represents a large country like China or India, and a small circle would represent countries with low population like, I don't know, Andorra or something like that, okay? So that's a visual property, an aesthetic attribute of the point. Points, you can also say, I want squares or triangles, depending on some other variable. You can change the color of the point, okay? Same thing with bars, okay? Bars will have heights, it will have X position or Y position, however you have your bar set up. You can change like the transparency level, if it's solid, opaque, or kind of see-through. You can change the color, you can change the outline. There's all sorts of stuff you can change about aesthetic attributes of a bar. Okay, with lines, there's not as much you can do. You can change like the thickness of the line. You can change whether it's dashed or dotted or something like that, a solid line. You can change the color of the line. I think that's about it for lines, okay? But these are all different things that are, possible for us to do. And then, so anyway, the mapping says we are going to match up this column of data values to this visual property, okay? We're going to say the gender of the person will be represented by the color of the dot. Blue dots will be this gender, red dots will be this gender, okay? We will say the, the year that they are in school, whether they are a first year, second year, third year, fourth year, or fifth year or higher, will be the, the type of point, okay? Circles will be first years, and triangles will be for second years, and squares will be, well, it probably makes sense to have triangles for third years and squares for fourth years, and I don't know what you do for a second year, but for circles, circles would be first year, and I don't know, maybe an X for a second year or something, I don't know, whatever, okay. But, you could have some kind of visual attribute of the point being mapped, the data being mapped to a visual attribute of the point, okay? All right, and so those are the mappings, okay? The scales control how that mapping is done, okay? The scale will say, we've got big values and small values, right? So I don't know, we wanted to graph, GPA or something, right? And so we can say high values, 4 will be graphed, represented with a blue dot, okay? And low GPAs, like a 0 or something, will be represented with, red or something. And you would have this color transition that goes from red to blue with something in the middle being purple and things like that. And the scale would designate that, okay? Now you might find in your data set that you don't have anybody with a 0.0 GPA, and maybe the lowest one that you're really seeing is like a 1, okay? And in that case you go, well, maybe I can make the red 1, and you can shift the way this mapping happens, right? You can also say, you know what, by default, Ggplot tries to map this category to this, but you know what, I want to say you want to use like little emojis for your symbols or something, and you can say, I want to map this this value to be this symbol on the graphic, okay? So a scale maps the values in the data to attributes, aesthetic attributes, okay? A guide is for the other way around. A guide allows the person viewing the graphic to then understand what each of these visual attributes represent, okay? So the problem over here with this was that there was no guide, okay? We saw visual attributes, black, gray, and light gray, but we had no idea what this represented in the data, okay? What we are missing is a guide. And so a legend is a type of guide in that says the color black, the visual property black color represents the data attribute B1, and the visual attribute of color gray represents the data attribute B2, and the visual attribute light gray represents the data attribute B3, okay? So when we have a legend, we have a guide that allows us to go from the visual back to the data, okay? Things like the vertical axis here that goes from 0 to 12.5 or whatever, this serves as a guide. It tells us if this was missing, we would see this tall bar, but we would have no idea what that represents, right? By seeing this thing on the vertical axis, this serves as a guide and says, oh, this bar corresponds to something around 12, and now we have an idea of what numbers exist in our data, okay? So these are things that are like very subtle that we're not aware of, but the grammar of graphics force us to be aware of what visual guides we have, things like legends and tick marks, that allow the viewer, because the whole point of the data visualization is that they don't have to look at the table of data to know what's in there, right? It's that they can just look at a picture and know the data that exists in the table, right? Or at least the important aspects of the data that exists in the table. And so we need to say, when you see a bar this tall, this represents a value of 12. And if we're missing this, the labels on the x-axis, that information would be lost. Okay, so we need guides, okay? All right, so here is a data visualization scenario that's kind of detailed out, all right? So we've got data, numeric or categorical variables. We have geometries to represent the observation, such as a point or a bar or something. And we might say, you know what, we want to have the aesthetic of this geometry to represent something. So we might say the vertical position of this point needs to represent something in the data, okay? So we might say the vertical position of the point represents, you know, some variable that goes from 0 to 10 or something. And so you have a scale that says, okay, if the data value is 0, that's going to go on the bottom of the graph. If the data value is 10, it goes at the top of the graph. And a data value of 5 will go to the middle of the graph, okay? Or, you know, depending on the scenario, you might want a logarithmic thing, which will say, I guess you can't have 0 as a, well, you know, you can have log 0. So log equal to 0. So you can say 0 goes at the bottom, 10 goes at the top, and 5 is going to be, you know, not right in the middle, but, you know, closer to one of the ends, okay? And so this is what we've done. This kind of just talks about types and guides. And when we think about aesthetic attributes, you know, some of the things make sense for continuous variables, like x position and y position make sense for continuous, whereas shape of the point only makes sense for a categorical thing. Okay, so let's look at a simple graph, okay? I'm going to start by creating this data frame. Okay, it's in tidy form. Each variable has its own column. We've got a column for x value, a column for y value, and a column for group, a grouping variable here. Okay, so it goes 1, 2, 3, 4 for x, 3, 5, 6, 9 for y, a, b for the groups. And I can just start off by saying create a visualization without any geometric objects. Okay, so we just say ggplot. And what we're going to do is we're going to map the x value column to the x position and the y value column to the y position, okay? And so because ggplot looks at the data, it automatically says, well, the x-axis needs to go from 1 to 4, the y-axis needs to go from 3 to 9, okay? And so it automatically kind of creates this space for us. But we haven't produced any objects, okay? So in this case, it probably makes sense to graph points, okay? So we're going to say the geometric objects we're going to graph will be points. And so all I do is I say, let's take ggplot, okay, same command as before, and add some points. Points for each observation, points for each row that we have. And it graphs the points just like that. To make kind of our commands easier, we can say make ggplot and store it into this object p, and then we can just call p plus geom_point, okay? And that would be the equivalent of what I have here, okay? Here I might say, well, you know what? I want to take that grouping variable column and I want it to change the color of the point. So we create another aesthetic mapping that says the color of the point is going to be determined by the column group in our data, okay? And so we do that, and I don't know if you guys can see it, but now we have red points and blue points in our graph, and red represents values of A, blue represents values of B, okay? And it automatically creates a legend for us, which is quite nice, okay? So the key here to remember is that a mapping represents a variable in the data being mapped to a attribute, a visual attribute, okay? That's going to be an aesthetic mapping. Here we said the variable group will determine the color of the point. On the other hand, if you say color is equal to blue, okay? This is a setting. This will say all the colors in our plot will be blue, but now that color blue does not represent any property in our data, okay? There's no variable being mapped to the color. The color blue doesn't represent any kind of attribute that exists in our data. So this is not a mapping, this is just a setting, okay? So here we can just say color is blue, and it makes blue dots on our graph here. Is that okay? So keep in mind the difference between an aesthetic mapping, which says a variable in our data determines a visual property, whereas a setting just says, I want this visual property for all of my dots. It's not going to represent anything in the data here, okay? We have the option to also change scales, okay? So here our x-axis was determined by the data, going from 1 through 4, but maybe we created a different plot where the x-axis went from 0 to 8, and we want to compare this plot with that one, and so we want to manually control the x-axis on our plot. We can say, well, you know what, let's change the scale so that the value 4 doesn't go all the way to the right edge of the plot, but it goes to the middle or something like that, and we go from 0 to 8, something like that. Okay, we will cover more of this on Monday, okay? You'll have the exam on Friday. What I'm going to do today, which I haven't done ever since the beginning of class, is I'm going to take a manual attendance roll call, okay? So